Okay. So today we will do L3 EVPN lab, right? The one basically what we discussed last time. So if you see here, we have leaf 1 and 1B MLAC pair, right? And that is connected to spine, and again leaf 2A, 2B. Okay. And these are the clients. So client 1, 2, 3, 4. You can consider this as a CE device, right? So behind that, behind this client, you have this subnet. So 10.1.10.1, right? This subnet is behind this client. 11.1 is behind this client. 12.1 and 13.1. And all are configured, connected to this leaf VTAP pairs, right? In particular, WRF tenant A. Okay. So all these different clients are connected to tenant A. VTAP does not have any SVIs. Okay. It's L3 EVPN. So we don't have any SVIs on this VTAPs. Okay. So basically what we will do is, let's say basically this client 10.1.10, all this client has eBGP neighborship with this VTAP pairs, right? So under this WRF, under tenant A WRF. So client 1 will advertise this routes, right? 10.1.10.0/24 subnet prefix to VTAP 1 and 1A and 1B, right? So it will advertise this prefix. Similarly, all other prefixes also will be advertised to this VTAPs. VTAP will generate type 5 route for this prefix. So it will generate type 5 route, right? Type 5 route for this prefix and advertise to the spine. Now we have IBGP. If you notice here, so this is eBGP. So 65111, 112, 113, 114, and these are 65001, right? So we have eBGP between client to leaf VTAP pairs. Between VTAP to spine, if you see same AS number, so it is IBGP, right? IBGP. So spines are acting as a route reflector. So spines are route reflector, and all this are four are clients. VTAPs are client. So whatever route you advertise to route reflector, type 5 route, right? It will advertise that route to other VTAP pairs. So that will be advertised to other VTAP pairs, right? And then type 5 route will be installed, will be received in EVPN routing table, and based on route distinguisher and basically RT, route target value, it will be installed into this WRF, tenant A WRF routing table. Okay. So this is how, and then it will be forwarded again to eBGP peer. So basically this guy, client will know, will receive route for 10.1, 10.1, 10.1, 11.0/24, all the routes, right? Through this peer, eBGP neighborship. Is it clear? Or if you want, I can explain you again. Is the topology clear?
Yeah, I think so. So you have like an external BGP neighborship with client 1, 2, 3, 4.
Yes.
You
Yes.
advertise the
Not between 1, 2. So basically eBGP neighborship is here. Yeah, just a minute. So eBGP neighborship is between client 1 and leaf 1A. Okay. And eBGP neighborship client 1 and 1B through this directly connected interfaces. Okay. So let me show that. So it's clear. Yeah. So let's.
you're advertising that /24 subnet,
Right.
and then in EVPN that's coming up as a type 5, and we're advertising it to the other VTAPs.
Yes. Yes. Through spine.
Yes.
Okay.
Yeah. Then that makes the leaf a border leaf, or
no, leaf is compute leaf. You can say it as a compute leaf. These are customer client devices basically. So this type of topology you might basically, or you can consider it as a, these are the VTAPs, right? These are the VTAPs, in your DC setup, in our DC setup, these are the VTAPs. We can consider this as a compute leaf as well, right? And behind that, you have clients where, you know, this subnet is only behind this client. Okay.
Mhm.
And this subnet is only behind this client. So this type of topology is quite rare in DC. But if you check about service provider, then you can consider this as a PE devices, right? All these VTAPs. These are called CE devices, customer edge device. This is ISP perimeter edge device, and this is P devices, right? So this is how this topology will be in MPLS. Or let's say you have two different data centers, right? That is this BLR and one is HQ, right? And you are using two different subnets. You do not have overlapping subnet between this two DC. So what you can do is you can advertise type 5 routes, right? This subnet and this subnet, you advertise using type 5 routes to other side, and similarly the other two subnets you advertise using type 5 within DC.
Okay. Makes sense. I guess it's like similar to like MPLS VPN v4 concept.
Yes. So it's a VPN v4. In fact, we just have to change, you know, one line, and that will be converted into VPN v4 config. Even VPN v4 is also supported with VXLAN data plane. So that is also there. So you can use that as well.
Okay, thanks.
Okay. So yeah, so let's say this is the BGP, right? Client one has this BGP and with this, right? So let's check that. So this is client one. Okay. Show LLDP neighbor. So ET1 is connected to leaf 1A and ET2 is connected to leaf 1B, right? ET1, leaf 1A, 1B. And these are the IP addresses. So show IP interface brief, right? So we have this two are the IP addresses, and this subnet which we want to advertise, that is our loopback one, right? So this is our loopback one interface 10.1.10.1/24. Okay. So we already have end-to-end ping running, right? So ping 172.31.254.1 is the other side towards spine, right? So that is working. Then we have configured BGP, right? So BGP router BGP 65111 neighbor, right? 254.1 is spine leaf 1A. This is leaf 1B, right? And we are doing redistribute connected. Just ignore network command. Okay, that is not needed. So we will do. Okay, let me remove, right? Okay, so this is the configuration that we have BGP neighborship with leaf 1A and 1B. This client one has, and then redistribute connected. So basically all this in routes, right? All these connected routes we are advertising. So if you check show IP BGP summary, show, right? We have two neighborship, show BGP neighbor 254.1 advertise routes, right? So basically we are advertising this route 10.1.10.0/24 and also other connected routes. Okay, so these are the routes we are advertising. So client is advertising through eBGP all the routes to leaf 1A, right? So is this clear? So this is the configuration, you know, on client, right? You have interface, loopback one, and BGP. Basically, you are advertising the route through BGP, eBGP to leaf 1A. Is there any question on this? Same config is for other clients. Okay. Okay. Now let's go on leaf 1A, right? So what is the configuration on leaf 1A, right? So show run interface VXLAN 1. Let's first check the VXLAN config. So yeah, VXLAN source interface, loopback one, encapsulation, MLEX system ID, right? UDP port and WRF to VNI mapping. So we have tenant A WRF. We are using this WRF, right? With VNI 10, right? So this is WRF to VNI mapping. If you observe, there is no SVI, configured, right? And there is no VLAN extended, no L2 VPN, L2 VLANs extended over VXLAN. It's only WAF, L3 VNI, right? So now these are the LLDP neighbors, right? So ET5 is the connection with client one, right? So we have ET5 connected to client one and ET6 connected to client two. So 5 and 6. So ET5 is connected to client one and 6 is connected to client two, right? So let's check the config. Interface ET5 and 6. So now both these interfaces are in WAF tenant A, right? Both are in tenant A WAF, right? And IP addresses. That subnet 254.1 and 254.3. Okay. For eBGP peering. So is it clear that we have this interfaces into WAF tenant A? This interface is in WAF tenant A. So whatever traffic comes from client, that will be landed into tenant A WAF. Okay. And if you check the BGP configuration, this is our EVPN overlay configuration, right? EVPN overlay. This is you are activating EVPN neighborship. These are the config which is, so you already know RD and RT value, right? So under WAF tenant A, we advertise route distribution and route target. Now this is the configuration neighbor which we have neighborship with eBGP neighborship with client, right? So under this WAF, we have to configure neighborship with client, right? 65111 and 65112. So these are two neighborships under WAF. Okay. This one and this one, right? This two neighborship. Okay. So these are two neighborship. One more. So yesterday when I was, building up or doing configuration, I did this much and this neighborship was not coming up. In fact, when I run show IP BGP summary, right? Can you tell me why I am not able to see any neighborship here?
Do you need the VRF?
Yes. So I need to give VRF, right? Okay. So yesterday when I configured this much, right? I was not seeing even neighbors here reflecting. Okay. And on client side, it was showing as just connect or active. Basically, neighborship was not coming up. The reason was because we need to go under this WAF, right? Like we were used to do IPv4 neighborship activate, right? For outside underlay BGP neighborship. Similarly, for this BGP neighborship under this WAF, we have to go to this address family IPv4 and activate this neighborship. Okay, then only this this guy will start sending BGP neighborship messages, basically initiate BGP peering. Okay, so you just have to make sure that this is enabled. This one is not needed. Okay, this is not needed. We have to enable it under WRF address family IPv4, then only it will initiate the connection. Okay, so as we can see here, there are two neighborships we have, right? And if you check show BGP neighbor, right? Neighbor received routes, WAF, we have to give WAF, right? And as we can see here, we are receiving this routes, right? 10.1.10.0. This BGP neighborship has advertised this route to us. So we are receiving that route. And also the connected interface route, right? This connected interface route, which has advertised by this client one. So we are receiving this two this routes. We are more interested in this one, right? This subnet we want to advertise. So now as soon as this, you receive eBGP, basically BGP route through eBGP. Because of this configuration, you will generate type 5 route, right? You don't need to configure redistribute connected. See, there is no redistribute connected, right? As soon as you receive this eBGP route, you will create type 5 route, because type 5 route, and advertise to the spine, right? So show BGP EVPN summary. So this is your EVPN neighborship with spines, right? EVPN neighborship with spine. Okay. And if you check here, show BGP neighbor, right? 255.1 EVPN advertise routes, right? So you are advertising this route to as a type 5 route, right? 10.1.10.0. That is nothing but this route. And 11.0 you will receive from client 2. So that also you will advertise to the spine, right? So if you want to check EVPN route type, IP prefix, IPv4 detail, right? So basically what you are doing is you have generated 10.1.10.0 route, right? From that eBGP route you received, you generated type 5 route. Okay. Extended community route target 1010. This is the route target 1010, right? What we have configured under WAF. So this is generated encapsulation VXLAN. This is router MAC, right? MLEC system ID and VNI 10, right? So this is the VLAN to VNI mapping we configured under VXLAN. VLAN to VNI mapping for this WAF to VNI mapping, right? So basically we are generating 10.1.10.0/24 route towards spine. And similarly, you can check the 11.0 route. Okay, received from client 2. Is there any question as far as config is concerned, or any if you have not understood?
I think it's okay for me.
Sorry.
I think it's okay for me.
Okay. Anyone has any question, or are you clear about the configuration?
Yeah.
Okay. So this is the configuration you will see with type 5 type L3 EVPN type 5, and you are sending type 5 routes. There is possible that you can have multiple WAF. So this is tenant A WAF. You can also have WAF tenant B. So basically you can have that this client is in WAF A, right? This client is in WAF A, and this client can be in WAF B, right? And you receive this routes into WAF B and then advertise into WAF B, right? And this route to A. So that is also possible. Basically, you can have multiple WAF, right? And you receive route in that WAF and advertise with different RDRT values, right? Like we used to do in different VLANs. So that is also possible, right? Here we have taken only one WAF, but we can have different WAFs. Each client can be in different WAF, right? So that is also possible. So let's check on spine now, right? So on spine, we have show BGP EVPN summary route, EVPN neighborship, right? From leaf 1A, 1B, 2A, and 2B, right? And what is the configuration? So we don't have to do any config change, on basically spines. It is simple EVPN neighborship, right? With all 4 peers, and then activate that. You have to activate that neighborship. Okay. So show BGP neighbor, right? This is the client 1. Sorry, leaf 1A received routes, right? Oh, EVPN, correct. So we have to basically specify EVPN here, right? For EVPN routes. So there should be EVPN, otherwise it consider it as a normal BGP. So as we can see here, you are receiving 10.1.10.0/24 route. If we want to check, we can check detail. So we are receiving 10.1.10.0/24 route, right? From this VTAP 192, which is leaf 1A, 1B, and with route target 1010 and EVPN route MAC and VNI 10, right? So basically we are receiving this route. You can also check same by route type, IP prefix, IPv4 detail. That what are the routes you have, right? So these are the routes you are receiving, and then BGP VPN summary, right? Show BGP neighbor. We are advertising this route 10.1.10.0 EVPN advertise routes. So basically this route, what we received from 1A, whatever received from 1A, 1B, it will be advertised to 2A, 2B, right? So this route 10.1.10.0/24 received by spine 1 from this 2, it will be advertised to 2A and 2B, right? So this is advertised to 2A 10.1.10.0, right? And if you go to leaf 2A, show BGP EVPN route type IP prefix, IPv4 detail. We can see that we are advertising this prefix route, right? Basically, we have received this route 10.1.10.0 from this VTAP, leaf 1A, 1B pair, right? From both the spines. So we have received this route, okay, with route target 1010, EVPN router MAC, and VNI 10. And as soon as we, so let's type this way, right? IPv4 10.1.10.0/24, right? So basically we received this route 10.1.10.0/24, and based on that we will push that route into the VRF, right? So 10.1.10.0 based on this received route, right? This route is pushed into the VRF tenant A routing table, VTAP 254.3, right? So this is the VTAP which has sent that route with VNI 10, router MAC, that is MLAC system ID of that 1A, 1B, and local interface VXLAN 1, right? So this is this route are, basically installed into this VRF routing table. Now, as you received this route, you installed into that VRF routing table, right? You also have eBGP peering. So basically you will advertise that route further to clients, right? So that's what we can see here. So show IPBGP summary VRF tenant, right? Show BGP neighbor. So this is client 3 neighborship, advertise routes, right? VRF tenant. So this 10.1.10.0/24, right? This particular subnet prefix which we received is now we are advertising that to the client 3. So basically the 10.1.10.0, this subnet which we have installed in this VRF, that we are advertising to client 3, right? And if you check client 3, right, you have route 10.1.10.0 pointing towards the leaf 2A, 2B. Okay. Is it clear? Any question? Any
So normally,
question? Yeah.
Leaf 2A is receive the route via IBGP. Normally, if we get something via IBGP, we share it to EBGP.
Okay. Yeah. So basically, IBGP to IBGP route will not be advertised, right? And for
Yeah.
that, you need to configure route reflector or full mesh, right?
Yep. Yep.
Whatever route you receive. Okay. So let's say this is IBGP, right?
Yeah.
And this is IBGP.
Yeah.
All this IBGP, right? Why we have to make this route reflector spines? Because otherwise, whatever routes received through IBGP, right,
Yeah, we don't advertise
will not be
to
advertised to this guy because because of loop prevention, right?
Yeah.
So that's why either we need to configure full mesh, that is this to this neighbor shape, right? Or we need to configure route reflector, right? So IBGP route is received by route reflector from client and it will advertise again. Okay. Now let's say, what if, you know, here we have EBGP, right? This is EBGP. What happens if I configure here IBGP? IBGP peering. And this is again same AS number, right? 65001.
So we won't advertise again.
So we receive route from here, right? IBGP. Will that route will be advertised to spine 1?
No.
No, right? Because it's IBGP to IBGP. What you have to do is you have to configure this as a route reflector so that whatever you receive here, you advertise it further. But already this guy is route reflector and this is route reflector client, right? So basically you have to design such a way that you know your routes are advertised. That's the reason, you know, I have configured here EBGP between these two. Okay.
But what you receive from IBGP, you normally advertise to EBGP, right?
Yes.
Like
so whatever I receive from EBGP, right? EBGP will be advertised to IBGP. So EBGP, EBGP to IBGP, right? And reverse, right? IBGP. And whatever I received from IBGP will advertise to EBGP, right?
Yeah, okay.
But IBGP to IBGP due to loop prevention, that will not work. Is it clear?
Yeah, all good. Thanks.
Okay. Any other questions? Or do you want me to explain it again? Okay. So now let me introduce one issue, right? Okay. Okay. Before that, let me go through one most common issue, right? So if you go through the slides down, right, there are some interesting issues and commands is given, so feel free to go through it. The one which I want to run through is this one, right, which we see a lot of time with EVPN, and that is this, that so this is your leaf, right? Two leaf pairs and spine connected, and you have host A and B connected, L2 EVPN, right? Now what if, you know, this both the host has same MAC, right? Same MAC 1, or basically there is a loop. This is somehow connected through L2 switch to this way, right? L2 loop. What will happen? Basically you will see MAC flap here, right? MAC flap here. What you will see, you learn this MAC 1 locally on, let's say, ET1 interface. And after some time, when this guy sends packet here from MAC 1, you learn that MAC over VX1, right? And through EVPN through type 2 update message, right? So basically your MAC will continuously flap between ET1 and VX1, right? And what happens if that is the case? Let's say at one point of time, you might see traffic drop, or one point of time your MAC is not at all learned, right? And you flood the traffic, right? Because MAC is not learned, you flood the traffic to all the VTAPs, right? And you might see traffic drop because you send some packet here, right? And similar at the same time you receive traffic here, you might end up sending packet, dropping packet, and all that stuff, right? So what EVPN does with this, when there is a MAC flap, right? There is a loop in the network or MAC flap, duplicate MAC, it is blacklist that MAC. So whenever you see that MAC address is moving for this particular VLAN, it will blacklist that duplicate MAC. Blacklist means what? It will stop sending type 2 route update. So basically, let's say it has learned this MAC here, it sends out type 2 route update, right? Type 2 route update. As soon as this guy also learned MAC and it sends type 2 route update, and this is now learned on VX1 interface. It was already learned on ET1 and now VX1, right? So if this happens for consecutively for 5 times or more within past 180 seconds, means last 3 minutes, if this MAC move happens 5 times or more, right? It will blacklist that MAC address. Basically, it will stop sending type 2 route update, right? Because there is no point of unnecessary sending type 2 route update, right? So it will blacklist that. So what happens? Because it has blacklisted, now you will not see MAC learned on this, right? Type 2 route is not updated. So basically you don't have that MAC learned over VX1, right? So what you will do whenever there is a traffic comes for that MAC, you will flood that traffic. So overall effect will be, if you have 50 VTAPs, you flood that traffic to 50 VTAPs, basically your uplink gets congested, right? So this is one scenario where you see, a lot of basically customer is saying partial packet drop. You first need to check this log message. If there is a, in EVPN, there is blacklisted MAC is there or not, right? Because in that case, or you see uplink fully utilized, right? In that case also you need to check that there is no blacklisted. Okay. So this is the one you can keep in mind, right? So what happens is, so as we discussed, traffic will be flooded to all the VTAPs, and there are 50 VTAPs, 50x traffic will go, right, for that MAC. So which can definitely uplink can be overutilized, right? So what you have to do is you can do clear IP blacklist, right? But if still there is a, loop or duplicate MAC is there, it will again come back, right? It will again block the, basically blacklist that MAC address. So solution is continuous MAC moves, MAC mobility, extended command attribute would continue to increment. So if you remember in type 2, we increment as soon as you send out, MAC update, you increment that MAC mobility counter, right? So that will continuously increment, right? And it does not go beyond, basically increment to infinity. That's why we need to blacklist this, right? We stop basically sending that type 2 update. So these are the commands: show BGP EVPN host flap, to just see, okay, if there is any MAC address, host flaps are there or not. And you can also clear this, right, to see if there is no MAC flap, you can basically clear this and check that, so that type 2 route updates will be started, and then you can validate, verify that if still there is a problem or not, MAC move. Okay. And you can also use this event handler where, you wait for 300 seconds and then clear this BGP EVPN host flap. So basically you, after 300 seconds, you just clear BGP EVPN host flap, that blacklist, remove it from blacklist. to see if there is no problem, then it will basically it will start working. Otherwise, once it is blacklisted and you don't understand that, right, that it is blacklisted, you continue to troubleshoot something else, right? So this, by this script, it will automatically clear the blacklisted one, and if there is still loop or duplicate MAC, it will again blacklist, but at least it will come out of that if there is no loop, right? So this is one of the most common case we have seen in EVPN. Any question?
Hey, I have one, Vishal. By default, we like, you know how we blacklist the Mac. By default, we clear it after some time, or it just
No,
stuck in
no.
the black
Yeah.
until we
So
clear
by
the Mac,
default,
right?
yes, by default we don't clear up, right? So that's the reason you, if you have this, that's the reason first of all that you should check for this message, right? Whenever you come across any traffic loss, this can be one of your check, right? Basic check that, hey, there is no blacklisted MAC, right? So, and if that is the case, you can try clearing it out and see if now there is no MAC flap, it's working fine.
Okay, thanks.
Yeah. Okay, any other questions? Okay, so let me quickly introduce some one issue. Let me stop share.
Yes.
Okay, so this is client one, and I'm trying to ping the other, other client IP addresses. So from here, I'm trying to ping the other IP addresses, right? Other clients. Ping 10.1.12.1, right? It's not working, correct? 13.1, not working. Previously, it used to work, right? It's not working. Okay. So can you tell me how can we troubleshoot?
Maybe first we can check the EVPN route from maybe leaf 1A. Let me get the command. Hang on.
Okay. So leaf 1A, what we want to check?
Show BGP EVPN route type.
IP prefix, IPv4, is it right? So yeah, which route you want to check?
I guess we're trying to ping, let's just say client 3, which was 12.1. So we see, looks like it's pointing to, yeah, this one.
So basically you have route for that guy, right? 12.1.
And the VTEP's correct. Like, I think next hop would be, no.
This VTEP, right? Yeah, so
Okay.
254.5, right? Yeah, it's a correct VTEP. So basically you can also check this, right? WAF routing table, basically route of that WAF, right? Because it is possible that you have received the route, you have in EVPN, but it's not installed here, right? So best is to check this one, that, hey, do we have route for 12.1 and 13.1, right? And is it correct? So yeah, it's behind VTEP 254.5, right? First of all, it's in under this same WAF. So that is one thing, right? We have route pointing to the next hop VTEP, right? VNI 10. And this is the MAC address of that guy, and over VXLAN, right? So basically you have route for 12.0 and 13.0, right?
Okay, yeah, it looks good. Can we maybe just check the like the route coming back on one of the leaves on the
2A,
remote side, and yeah,
2A, right?
and maybe just
Okay.
the yeah, and we can
Show
maybe
IP
just check
route. Yeah, VRF tenant, right? So yeah. So you have 10.1.10.0 and 11 routes.
and maybe we can just check the router MAC is correct.
Oh, router MAC. Yes. So this is the one, right? 08E7, this side. Show AMLAG system ID. Show AMLAG, sorry. Yes, 08E7, right?
So are both the leaves advertising those routes to the client devices?
Okay. So let's check on leaf 1A. You mean to say, is it leaf 1A advertising this route, right?
Yeah, the 12. Yeah.
Which route? Okay, so
The
let's say,
12.0.
yeah, BGP summary WAF, right?
Yeah.
Yes, so these are the two BGP neighborship, right? Towards client. So show BGP neighbor, this, right? What is that next? Advertise routes, WAF tenant, right? Yeah. So 12 and 13, right? And 11 as well. So all three routes are advertised,
Okay.
right?
Okay, and they're installed on the client side, or?
Okay, yeah, let's check that, right? Client 1, show IP route. So here there you don't have any WAF, right? So client don't have any WAF. You have WAF here local. So on client, it's a normal default route, right? Default WAF. Yeah, so you have this 11.0, 12.0, and 13.0 routes are there.
Okay. Confirm the same for the other side, 2A side.
Okay, so 2A, right? Show IP BGP summary WAF tenant, right? Okay, show BGP neighbor 8, advertise route WAF tenant. Okay, so you have 10 and 11 advertised, right? To the client 3, right?
Yeah.
And now you want to check here, right? Client 3, show IP route. Yeah, 10 and 11 is here.
Okay. So the routes are there for the end-to-end connectivity, but it's not working.
Yeah. How can we,
So, yeah.
I think, I don't know, it looks like control plane looks okay. I'll probably trace the data plane packets.
Okay. So how should we trace?
If it's virtual, I think we can do a TCP dump.
Okay. Where should we do TCP dump?
I would probably start off with leaf 2A.
Leaf
I think
2A.
we can probably, yeah,
Okay.
I think because it's like a lab, we can probably just do TCP dump interface any, and then just do filter host.
Okay. Fine. So basically, see, the problem is client 1 is not able to, let's take 1, right? So client 1 is not able to ping client 3, right? How we check that? We have route here for 12.1, right? This route is here. Basically, we are advertising 10.1.10.0 here, and that is advertised throughout this. This guy has 10.1.10.0 subnet and also here. And 12.1 is also everywhere, right? So basically, control plane, it's all good, right? Now we want to confirm where traffic is getting dropped, right? Where packet is getting dropped, right? Data plane, correct?
Yeah.
So what should we do? So one you mentioned is, take TCP dump, but it's a data plane traffic, right? Will you be able to see in TCP dump on
Not in like a
VTEPs?
real app. You need to mirror to
Mirror.
CPU.
Okay, perfect. Yeah. But there are a lot of traffic, right? So it's in a production environment where you might not see that correct particular ICMP request.
Yeah, we can truncate the packets,
Yes,
but
that's right.
yeah, sometimes if there's a lot of rate, it can be hard. Yeah,
Yes,
because we
but
rate limit. Yeah.
yeah, that is the way we can do truncate and rate limit, right? So that's right. But before that, which packet we are looking at, right? Are we missing ICMP request? Basically, we also want to understand which direction packet is dropped, right? That will give us more idea, correct? So how can we first understand that whether traffic is dropped here or this side?
We can do a captcha on client 3 and ping from client 1, and then do the opposite, ping from client 3 and do a captcha on client 1, and then we should see if the request makes it to either
Yes.
client. Yeah.
Yes. So let's first identify, right, where the basically where with forwarder, and before that, I think we can also do trace route, right? Trace route 10.1.12.1. So where it does go, 54.1, 31 to 54.1. Okay, it's not going after that, right? Okay, so we need to, okay, let's do this, right? TCP dump. What was the interface? Show LLDP neighbor. ET1 and 2, right? So let's do TCP dump interface ET1 ping 10.1.12.1. Okay, so we got something here. Yeah,
we get the request, but we never even send the reply. So something on this guy
okay,
looks like it's wrong.
okay. Do you guys, yeah,
Maybe something with the IP. The source looks a bit weird. Should be source. We need to ping from the source 10.1.11.1.
yes. So let's ping from the source, right? 10.1.11.10.10, sorry, right? 10.1. This guy.
Yeah, sorry. Yeah.
Okay, now it's working, right? But if you remember, I don't know if I have showed you or not, but when before I introduced this problem, when I was pinging like this, it was working fine. This ping was working fine, right? But after I made changes, this stopped working. But yeah, your point is right that, so basically just keep in mind from here is that you have to take the source, right? And that's why you can take capture to see which source you are receiving the traffic, right? And why we are not replying back, this guy is not sending reply back, is because this route for this guy is not there, right? It's not there. So yeah, in any case, basically troubleshooting steps will remain same what we discussed, right? When there is a ping between this to this is not working, you can follow the same troubleshooting steps. First, check the control plane is proper or not proper on each devices, and then you can try trace route, right? Or basically try to narrow down which side has a problem, right? And based on that, you can troubleshoot.
So I didn't get here. Was there a problem or?
Sorry?
Or we just was a ping just going not from the source? You're saying that before, even without the source, the ping was working.
Yes, yes, yeah. Because so what? Let me show you what changes I have made. Right. Okay. So
Did maybe before you were advertising the 172 address?
yeah. So before that, what I was doing is I had a redistribute connected, right? Router BGP tab, redistribute connected.
You're typing on all the tabs, yeah.
Yeah. So above that is no config, so that will not take effect, only down.
Okay.
Yeah. So yeah. So this was my before, previous config, right? So basically I was also advertising. See if I have to show you the ping, right? Ping 10.1.12.1. Now it works, right? What is the reason? Because now I have also advertised that 254 subnet. This one.
Okay. Is connected, yeah.
Yeah. So I am advertising now all the subnets connected, directly connected subnets. This, right?
Yeah.
And when I removed redistribute connected and just applied this, I was just advertising this subnet network. Okay. But yeah, basically we wanted to, understand how to approach troubleshooting. So this is what we followed, right? That is how we should troubleshoot. And once we find out, let's say, problem is with this direction, right? Then as Kamil mentioned, we can have TCP dump with mirror, basically mirror on this devices. So first of all, in that case, right, the best next step should be is, let's say, client 1, 2, 3 traffic laws in this reverse direction, right? This direction. What we should do, we can do first is we can apply ACL here, right? Apply ACL here and here, right? To count the packet source source IP this, destination IP this, and ICMP, right? Obviously, ARP and all that is cleared and everything is learned, and we are sending ICMP requests, right? We can apply ACL to count number of ICMP requests as received here, right? Whether, let's say, we send 10 ICMP ping, right? And we see total loss or half loss, partial loss. So we should see 10 is received here out of combination of these two. And we can have egress ACL here, right? Sorry, egress ACL here to confirm that 10 has received, gone out ICMP request, and ingress ACL to get that, hey, are we receiving 10 reply or not? And again, egress ACL to check whether we are sending out all 10 or not, right? So basically that will confirm that are we dropping packet in this fabric or outside of this fabric. If it is outside of that fabric, then we have to, troubleshoot there. But if we are dropping packets out inside this fabric, right, which is the case like this, where we are receiving 10 packets, sending out 10 packets, reply is 10 packets, right? But reply going out is only 5 packets. So basically 5 packets we are dropping in this fabric. And after that, what we can do is we can have mirroring, port mirroring with truncated, and that way we can troubleshoot further that which particular device is dropping that packet, right? Okay. So yeah, this is how, and obviously, yeah, we can go through each device to see, there are no congestion on links, out discard, or there is no blacklist, or no MACMU, right? Or no high CPU. So these are the other basic checks we will do on these devices, right? And then if still we are not able to narrow down one device, then yeah, we can do this truncation and all that stuff. You can refer basically EVPN that troubleshooting, right? Where this packet drops and that is there. So for EVPN, so one is basic checks, right? What are the basic checks you can do, and then packet drops, high CPU, Mac flaps. So you can refer this documents if in case, just to make sure that you are not missing any, to check most common stuffs, right? Okay, so with that, we are done with EVPN sessions. Any questions?
No question, Vishal.